Okay, so we're on part 2.1. It's too early to say this that it is our intro, so let's get to it. Philip, a space program researcher, would like to provide fresh fruits and vegetables for astronauts in orbit. However, Philip is concerned that high levels of radiation in space may disrupt the nutritional value of produce. One day, he picks 40 identical apples and randomly sorts them into two groups. The 20 apples in one group are exposed to radiation, while the other 20 apples are not. The apples are stored in otherwise identical conditions. After some time, Philip measures the amount of vitamin C in the apples. So the mean here is just 6 in here exposed to radiation, and then not exposed to radiation is 7.5 as the mean here. So how much lower is the average for the treatment group than the average for the control group? So I'm going to say that is 1.5, because 7.5 minus 6.0, or just 6, is equal to 1.5. So I'm going to say that. We're going to check if it's correct or erroneous. Let's go. Yeehaw! We know it worked. That's how you do it, guys. We hope you enjoyed. So we'll see you on part 2.2. Au revoir! Okay guys, this is part 2.2. Let's get to it. After completing the experiment, Phillips wants to see if the difference between the averages for the control and treatment groups was due to the treatment or not. To investigate this, he performs a significance test. The first step is to do a simulation using the data. He randomly organizes all of the data into two groups, A and B, each size of 20. In this simulation, Group A plays the role of the treatment group and Group B plays the role of the control group. The mean for A is just 6.85, while for Group B the mean is 6.45. So remember that the average for the treatment group was 1.5 lower than the average for the control group in the original experiment. Philip wants to compare this with the simulation results, so he subtracts the average for Group A from the average for Group B. What is this value? So we can just do B minus A in this scenario. So it's just 6.45 minus 6.85, which just negative 0.40. So we're going to check if it's correct or erroneous. Let's go. Yeehaw! Well, I know it worked. That's how you do it, guys. We hope you enjoyed. So we'll see you on part 2.3. Au revoir! Okay guys, so this is part 2.3. Let's get to it. After performing one simulation as the first step in his significance test, Philip does 99 more. For each simulation, he randomly reorganizes the subjects into two groups, A and B, of size 20. In the simulations, Group A always plays the role of the treatment group and Group B the role of the control group. After each simulation, he subtracts the average for Group A from the average for Group B. The distribution of the differences for all 100 simulations is shown in the following histogram. So we're going to be focusing on, in the original experiment, the average for the treatment group was 1.5 lower than the average for the control group. So just this one right here. So in what percentage of the simulations is the average for Group A at least 1.5 lower than the average for Group B? I'm going to say 2%, because 2 out of 100. So we're going to check if it's correct or erroneous. I'm scared. Yeehaw! We know it worked! That's how you do it, guys. We hope you enjoyed, so we'll see you on part 2.4. Au revoir! Okay guys, so this is part 2.4. Let's go. Philip is now ready to complete his significance test. He uses the simulations to determine whether the findings of his original experiment are significant at the 5% level. So yeah, in the original experiment, the average for the treatment group was 1.5 lower than the average for the control group. Each simulation reorganized the subjects into two groups, A and B. Group A played the role of the treatment group, and Group B the role of the control group. Philip found that in 2% of the simulations the average for Group A was at least 1.5 lower than the average for Group B. Based on this result, are the findings of the experiment significant at the 5% level? So, alpha in this scenario is going to be 5%. And then the p-value is going to be, let's say, 2%. So we discussed about the decision rule when we previously done a similar question to this in part 1.4. So I'm going to say yes, it is significant because 0.02 is less than or equal to 0.05. So we're going to check if it's correct or erroneous. Let's go. Yeehaw! But you know it worked. That's how you do it, guys. We hope you enjoyed. So we'll see you on part 3.1. Au revoir!